guys, so in this class we are going to be talking about the concept of set theory. The concept, we want to know the details of what set theory entails. Actually, this video will be in series, but in this particular video we'll be explaining basic terminologies that you need to know that pertains to set theory. Okay, so I want you to take note of each terminology so that it won't be a problem when we get to start solving questions in the subsequent videos. Okay, so before we can do anything in set, we need to know the definition of a set. What is a set? A set is a collection of well-defined objects. Well-defined objects are well-defined. Okay, now when we talk about well-defined, the word well-defined needs to bring a particular meaning to our mind. Well-defined. Okay, well-defined means the elements of the sets, they are governed by a particular rule. They are guided by certain rule. All members, they are guided by a certain rule. That's why we call it well-defined. A set is a collection of well-defined objects. Okay. Now, elements in a set, they are known as members of a set. For example, we have A. Don't forget, another thing you need to know is that a set is denoted by a capital letter, while the members are denoted by a small letter. So this A is saying that it's set A, while this ABC, they are talking about the elements. You can also say that they are the members of A, right? They are the members of set A. So number one, we need to know that the set is a collection of well-defined objects, and also it is represented by a capital letter in a curly bracket, and the elements or the members, they are in small letters. Okay, so let's move to the next term that we need to know that concerns set. Okay, all right, so let's see forms of set representation. Forms. What are the forms that we can represent set as? Number one, we can represent set as a roster form, and we can represent set as set builders. These are the forms we can represent set as roster form and as set builders. So let's quickly explain those ones one after the other. So when we talk about a roster form, we are saying that in this type of set representation, the sets are clearly spelled out. They are clearly defined. We can see them. We know where they are starting from. We know where they are ending. We recognize the whole member of this set. For example, if I have a set A, actually it can be any letter. It can be B, it can be C, depends on what you're working on. 1, 2, 3, 4. Let's just stop at 4. Now, I can know that this set A is explicitly defined to have elements 1, 2, 3, 4. They are clearly spelled out as 1, 2, 3, 4. Nothing hidden, nothing is there, nothing is not clear to us there, because we have all the elements spelled out. So this type of representation is known as roster form, right? Where all the elements are clearly spelled out. But in the case where we have set builders is a type of representation where the properties of the members of the set is encoded, right? It's actually coded. For example, if I have a set E, let me use another letter so it won't look like I'm using only A. Set E, and I have X, the X here. Okay, I have this one. Okay, and I have X greater than 3. Right. So this actually means this particular word. It means that a set E is a set of all elements of X, such that X, this X here, is a member of the set of natural numbers. That's the meaning of this whole thing. And we know that our X is greater than 3. Alright, that means whatever elements we'll be having in this particular set is greater than 3. So I will be having, my elements will be 4, 5, 6, and so on. Alright, that is the meaning of this. Greater than 3, 5, 4, 5, 6, and so on to infinity. So the major difference between roster form and set builder form is that the roster is clearly spelled out, that means the members, and the set builders, they are encoded with a particular expression. So let's go to the next term that we need to get familiar to if we actually want to understand the concept of sets. Okay, let's quickly check. The next one is the types of sets. We have two types of sets, basic two types of sets. Number one, we have the finite set. We have the finite set, and we have the infinite set. Now, from the word finite, it means, when we talk about finite set, it means all the members of the set are known. Everything, we can see everything. We know where it's starting from, and we know where it's ending. Right? So, finite type of set is where all the elements of the set are known. Right? They are easy to recognize. For example, if I have A is a set of 2, 4, 6, and 8. That means I know that this set is starting from 2 and is ending 8, and this is obviously a set of even numbers between 2 and 8. So it is clear where we are starting from, and it is clear where we are ending. But for infinite, it tends to be at infinity. Alright, we don't know where it's stopping. For example, if I have something like this, 1, 2, 3, then dot, 3 dots. Now, for infinite set, the way you can easily recognize them is that they have 3 dots at the back. 3 dots means in the same manner, in like manners, following the same rule that is guiding the members of the set. Okay, so this actually means that there are still more to 1, 2, 3 that you are seeing here. There are still more to that. We have more elements in that case. So types of sets, we have finite sets, all elements are known. Infinite sets, there are still more to what you are saying. Okay, so that is just that. And most of the times, some textbook we write, let me say I have E. Some textbook we write it as 1, 2, 3 dot, and some can even write to this infinity. This symbol shows infinity. Now some of you must have misinterpreted this symbol to be a number. It's not actually a number, it's just a representation of the fact that there are still more to what you are saying. It's not a particular figure, it's not a number that you are representing. So it's just a representation of continuity, no ending. Alright, so let's look at the next concept that we need to know that will help us to understand this set theory very well. So the next one we're going to be looking at is equality of sets. Equality of sets. Set equality or equality of set, anyone. Now set A is said to be equal to set B, or set A and set B is said to be equal if they are exactly, let me write set B. Now these two are said to be equal if they are exactly the same element in A and the same element in B, regardless of the arrangement. Okay, regardless. If I have A to be 1, 2, 3, and I have B to be 3, 2, 1, regardless of the arrangements, I can say for free that A is equal to B. So this is actually very, very equal because we have the same and exact elements in A and we have the same exact elements in B. Alright, so that's how to do this equality of sets. So let's move to the next one. That will be subsets. Now, subset is very, very interesting because there have been a lot of misinterpretation of what subset is. Let's take at this. We already know what subset is from our basic classes and all of that. But look at this. If I have this sign and this sign, most of us, we must have seen this before. We might not be really familiar with this second one, right? Now, this one, we always call it subset, which is not. Right? The right word to use for this one is proper subset. Proper subset. Alright, this proper subset, that's what you're supposed to say. And this one you're supposed to say that this is an improper subset. Improper subset, because what's the major difference? Let me just clearly give you this major difference. Now, for A, if I write B now, is a subset of A. Note, I call this a subset, or you can call it improper subset. Improper. Alright, I can call it proper subset or improper subset. I can call it improper subset or subset, sorry. Now, we have B as a subset of A. This is saying that if I have A to be 1, 2, and 3, and I have B to be 2, 1, and 3, I can say that B is taken from A, and also B is equals to A. So that's the meaning of a subset. A subset is that number, that set is equal to the larger set, all right, and that larger set is also equal, and we can also take it from it. And wait, before I continue, I can also say that what is a subset? You need to know what a subset is. A subset is a derivation of a smaller set from a bigger set. That's just the meaning of subset, because some of you might be thinking what a subset is. A subset is just like bringing a smaller part of something to form another one of its own. Alright, so just like a big school now, a classroom is a subset of the whole school. Alright, because the classroom is also part of the whole school. So that's not a subset. Now I'm just trying to give a clear difference between proper subset and improper subset. So improper subset, or what we need to call a subset ordinarily, is when both are equal, and you can also say that we can get it from each other. So the case of this other one is that if I have A as 1, 2, 3, and I have B as 2 and 3. Now this is a proper subset. B is a proper subset of A, because at least there is still one element in A that is not in B. So that is the proper way a subset should be. That's what I call proper subset. The proper way a subset should be defined is that there will still be at least one element in A that is not in B. So that's the major difference. So when next you see this symbol, this one, it means that all of B is still in A, and you can also call it a subset. But whenever you see this one, it says that there is still one element in A that is not in B. So we say that is a proper subset. So let's go to the next terminology quickly. The next term. Okay. So we can have a clear board to work with. Okay, our next one will be power sets. Power sets. Power sets. Now that we know that a subset is a smaller set that is derived from a bigger set, now power set is just telling us that is a set of all possible subsets of a particular set. It's just all possible subsets of a particular set. Like the possibility of getting a particular number of sets in a subset is power set. So for further knowledge, we talk about cardinality of a power set. Cardinality is just saying that the number of sets that can be derived from the number of subsets that can be derived from a set. If I have A to be equal to A, B, and C. Now, how many subsets can I get from here? Somebody can wake up and say, okay, I can get a subset W, and it will just be A. Somebody can wake up tomorrow and say, hey, I can have a subset Q, that will just be B. And we can just go on and go on like that. So what is the exact, without stressing ourselves to spell it out, we can actually know the numbers of possible subsets we can have. That's the cardinality of power sets. That means the possible number of subsets we can get from a particular set. So in that case, it has a formula actually that we can work with. The cardinality is given by test of a power set. Let's see, of set A is given by 2 raised to the power k, where k is the number of what? Is the number of elements in that set. The number of elements. So in this case, I have how many elements? 1, 2, and 3. So to know now, I have 2 raised to the power 3. This is to say that there are 8 possible subsets that can be formed from this. Is that true? Let's check it out. If it's actually true that we can get 8 subsets from this set A. Let's check if that's actually true. Let's confirm if that's actually true, so we can be sure that there are exact 8. From this I can get, let's get a larger set. I can get set A. I can get set A. I can get a set B. I can get a subset C, isn't it? I can get a subset AB. I can get a subset BC. I can get a subset AC. Right? 1, 2, 3, 4, 5, 6. Okay. I can even get a subset of A, B, C. Right? And I can get an empty set. So that is, so we know that we have 8. 1, 2, 3, 4, 5, 6, 7, and 8. Now an empty set is a subset of every set. An empty set, you have to know that word. An empty set is a subset of every set. Okay, let's go to the next term. That is a universal set. Universal set is very, very simple to understand. A universal set. So what is a universal set? A universal set is a set that embraces all smaller subsets. It embraces all smaller subsets, and it can be denoted by this. You can either write it like this. Let me try if I can write that, or you can either denote it by this. Yes. So most of the people are not convenient with this one, so you can go for this one. It's very simple to draw. This is just a moon. That's moon, right? Okay, so the next one is union set. What's a union set? Union set is the unison of 2 or more sets to become a single set, right? Union set is unison, joining 2 sets together or 2 or more sets together. Let's assume I have a set A. All right, I have a set A. 1, 2, 3, and I have a set B. A set B is saying 2, 4, and 6. And you're asked to find the unison. That means A union B. Very simple. That means I'm going to join everything together. I have 1 here, I can put 1 here. I have 2, I have 3, I have 4, and I have 6. Okay? So that will be the union of these 2 sets. Another one is intersection of sets. Intersection of sets. Very simple to deal with. Intersection. It just means that the property of sets. This property of set reveals that there are common elements in 2 or more sets. For example, if I have set A, as I've said, you can use any other data, but let's just use set A for this video. 1, 2, 3, let's say 4. Okay, 1, 2, 3, 4. And I have another element, another set B. 2, 4, 6, and 8. 2, 4, 6, 8. Now, intersection. That means A intersection B. It means that what can you see in A that you can also see in B? You have 1 here. Do you have 1 here? No. You have 2 here. Do you have 2 here? Yes. So that is 2 is common. You have 3 here. Do you have 3 here? No. You have 4 here. Do you have 4 here? Exactly, yes. So you have 4 here. Actually, I have 6 here. Do you have 6 here? No. 8 here? No. 8 here? No. So A union A intersection B is 2, 4. Very simple. Very, very simple. So just find something common in A and B and write it down. That's intersection of 2 sets. Okay. And note this word, that if a set, for example, let me give an example. If a set A is 1, 2, and 3, right? And a set B is 5 and 9. And you're asked to find the intersection of these 2. Obviously, there's nothing common here, right? So you write it as what? An empty set. And the term used, because in an examination they can ask you, when there is nothing common between two sets, what is that called? It is called that it is not that this set is what? They are disjoint. These are disjointed sets. They are disjointed. Right? There's nothing common between them. They are disjointed. So you have to know that. And that takes me to empty set. So empty set is when an event does not exist. Like in this case now, the event of intersection between A and B does not exist. So empty set means it does not exist. The event does not exist. Alright, let's check another term that we need to know. Another terminology that we need to know. Very important. Complement of a set. Complement of a set. What is the complement of a set? The complement of a set is just this particular element that is in the universal set that is not in the given set. Let's assume we have a universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, and we have another set A that is 2, 4, 6, 8, 10. No. Okay, let me take off this one. Sorry, let me take off this one. Okay, let's say we have another set like this. 2, 4, 6. Sorry about that. 2, 4, 6. Now, if I'm asked to find the complement is by A prime. Right? Complement means what do we have in the universal set here? Universal set, the whole of this, that is not here. You can trace. In fact, I can even put the 8. Because if I want to put it, sorry, I can even put the 8. I have 2 here in this place. I have 4. I have 6. I have 8. But we don't have 1. We don't have 3. We don't have 5. We don't have 7. We don't have 9. Yes, we don't have 10 also. So the complement of this set will be 1, 3, 5, 7, 9, and even 10. So the complement of a set is just saying that those set of elements that are not in that subset or a set, but they are in the universal set, that is the complement of a set. So the complement of this set A are the ones that are supposed to be there but are not there. Alright, so that's the meaning of complement. So let's look at the last term. That's difference of sets. Difference of sets. It can be difference of 2 sets, 3 sets, depends on the question you are presented to. You're presented with. Okay. Difference of a set. Let's assume we have sets A as 1, 2, 3, 4 to 10, and you are given a set B as a set of even numbers from 1 to 10. Okay, from what we did earlier, you know that this is the 2. This is actually set builder, right? This is set builder. Okay, so if I want to get A minus B, that means the difference between this now. It means that after I must have stated out A, I will remove everything that belongs to B from A. So let me state out all the elements of A. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is for A, right? And for B, I have even numbers only: 2, 4, 6, 8, and 10. This is for B. So A minus B. So we are starting from A minus B. So A, any property of A, any property of B here, remove it. So we have B here. B will be like, this is my property, so I have to take it away. This one is my property, I have to take it away. This is my own, and this is mine. This is mine. So these are the ones that belongs to B. So what are the ones remaining? We have just 1, 3, 5, 7, and 9. A minus B is found. But mind you, A minus B is not the same thing as B minus A. Is not equal to B minus A. Let's check that out. Let's check that out, because we need to be very sure, because some student might make the mistake to think A minus B is the same thing as B minus A. If I have, from here also, this is B. If it is B minus A, that means I need to first state out the element of B and remove the element of A. If it is A minus B, I will state out the element of A and remove element of B. But now it is B minus A, so I will state out the element of B and remove A. So let me state out the element of B now. The element of B are 2, 4, 6, 8, and 10, right? So let me remove those that belong to A. 2 belong to A. Okay. This, and this. In fact, everything belongs to A. So B minus A is equals to empty set. So in the next videos, we are going to see, in the subsequent videos, we are going to see more about sets that will be dropping.